Hey guys, this is Mr. Anziano. I'm going to record a quick video here on the Piecewise quiz that we looked at in class today. So first things first, guys, we need to realize that this first function is a square root function. Okay, so in order to graph those, it's going to be a lot easier if we make a table, like it says in the instructions, right? So we're going to make a little XY chart where our first objective is to find the x value that's going to make this square root expression turn into 0. Okay, so we look at the x value, right? We say, okay, negative x minus 3 is supposed to equal 0. How do we make that happen, right? Well, if I put a 3 right there, then I'm going to have negative 3 minus 3, which gets me negative 6. But I know that 3 minus 3 is 0, so how do we turn this into 3? Well, if we make it a negative 3, right, that means we're plugging in negative 3 minus 3. Right, and negative 3 gets us positive 3, right? So 3 minus 3 is 0. Therefore, when x is negative 3, we get negative 3 minus 3, which is 0. The square root of 0 is 0, and 0 plus 2 is 2. All right, so we have the point negative 3, 2 on our graph. Next, we find the next best square, which is going to be 1. Okay, so we say, all right, what do I need to plug in for x here to get 1 inside the square root? The answer is going to be negative 4, right? If I plug in negative 4, I get negative 4, which is positive 4. 4 minus 3 is 1. The square root of 1 is 1. And 1 plus 2 is 3. So when x is negative 4, y is 3. And the next nice square that we need to complete our graph is going to be 4. Okay, so what number do I plug in for x to get 4? All right, well, I know that if I subtract 3 from 7, I'll get 4, right? So this just needs to be a 7. So we're going to use negative 7, because then negative 7 is positive 7, and 7 minus 3 is 4. The square root of 4 is 2, and 2 plus 2 is 4. So we have those 3 points to create that graph. So I'm going to plot them. We have 1, 2, 3, negative 3, positive 2, puts me right there. And then we have negative 4, 1, 2, 3, 4, positive 3, 1, 2, 3, puts me right there. And negative 7 is right here, positive 4 is up here, so negative 7, 4 is right there. All right. Now we look at the domain. The domain is telling me to graph this function from negative 7 up to negative 3. We're going to be closed. Oh, lost my lights. We're going to be closed at negative 7, but open at negative 3. All right. I'm going to pause for a quick second, get the lights back on. All right. So now I need to connect my dots, right? So we have a closed circle at negative 7 and an open circle at negative 3. So I'm going to make that a really big, dramatic closed circle, and I'm going to erase that dot that I put at negative 3 and replace it with an open circle instead. And then I know that my square root function is going to have this shape. It's going to curve going up and to the left. Okay, and that's the first piece of my piecewise function. The next two are only linear, so we really don't need to make tables for those. We just need to know how to graph a line. The y-intercept of the second function is 4. 1, 2, 3, 4. There it is. And from there, I'm going to go up 1 and right 2. Or, if you want to think about it this way, we're going to go down 1 and left 2. And then we create our line. Okay, so we say, all right, this graph, or this line, is going to look like that. How much of that line are we interested in? We look at the domain. We only want it from negative 2 to 2. So we know that we're going to have a closed circle at negative 2, open circle at positive 2. So right there at negative 2, we have a closed circle, and I'm going to erase everything I drew to the right of positive 2, because we don't want that, right? We're only going up to 2. And we put an open circle there. Okay, and the third piece is also a line, negative 2x plus 1. My y-intercept is 1. My slope is negative 2, so I'm going to go down 2 and right 1, down 2 and right 1, down 2 and right 1, down 2, right 1, and why not do one more? All right. So there's my line for the third function, and we know, I'm just going to kind of go ahead here, looking at the domain, I only want x greater than 2. So I'm going to draw my line, connect the dots, but only starting at where x is 2. And because we're not bounded on the right, I know that I can put an arrow at the end of that and just put, I'm going to erase that dot right there and put an open circle right there when x is 2. Okay, so that right there is what your piecewise function should look like for this first problem on the piecewise quiz. And then moving on to the back side, it says evaluate the following piecewise function at the given values. Remember to write undefined if the value does not fall in either domain. Okay, so we have 6 values to try. All right, the first one is g of -5. Well, we notice, guys, that at -5 we have an open circle. So technically, -5 is not a part of the domain for the first one, and it's definitely not greater than 0, so we write down undefined. Now, when x is -2, we know that -2 is going to fall between -5 and 0, right? So we're plugging -2 into the first function. 3 times -2 plus 4. That's equal to -6 plus 4, which is -2. Okay. G of 0, well, 0 is one of those tricky ones. It's either going to it's going to fall into this first domain, or it's going to fall into the second domain, right? Well, in the first domain, we have a closed circle at 0, which means that technically 0 actually belongs to the first one. So we're going to plug 0 into the first function as well. 3 times 0 plus 4 is equal to 0 plus 4, which is just 4. Okay. Next we have g of 2, right? And g of 2 tells us that we are going to belong in this domain here because 2 is greater than 0. So we do -1/2 times 2 plus 2. -1/2 times 2 is -1, and -1 plus 2 is +1. Okay. Do the same thing with 4. 4 is greater than 0, so we're using the second function. -1/2 of 4 is equal to -2. -2 plus 2 is equal to 0. And finally, 6 is also greater than 0, so we do -1/2 times 6 plus 2. And that's equal to -3 plus 2, which is -1. All right, and there you have it. Right? Remember, if -5 is one of those values that is on the borderline of the domain but does not fall in it, we write undefined. If we were trying to evaluate something less than -5, right? If we were asked to evaluate -10, for example, we know that that's clearly not going to fall into either domain, so -10 would also have a value that is undefined. All the rest of them, though, we were able to plug them into either one of the 2 functions and get an output, right? So that's what graphing piecewise functions and evaluating piecewise functions at given values is all about. All right, be ready for another quiz that looks kind of like this one. Thanks, guys.